Exercise 5.7 Continuity and Differentiability. We have completed 11 questions. Now we will go for the 12th one. If y is equal to cos inverse x, find d square y by dx square in terms of y alone. So they have given inverse trigonometric function. Y is equals to cos inverse x. So this is an inverse trigonometric function. So we have to find d square y by dx square. That is, we have to find the second order derivative. Right? So function is given to us. We have to find the second order derivative. For that, we have to differentiate and find first order. Differentiate again and find the second order. Right? But they have given a condition that it should be in terms of y alone. So that I will explain after we get d square y by dx square. So given y is equal to cos inverse x. So whenever you get an inverse trigonometric function, so you can write here, this implies if y is equals to cos inverse x, if you do the composition, you get x is equal to cos y. Right? So whether it is useful or not, but whenever you have inverse trigonometric function, you make sure you write this step in one side. Okay. Now we want dy by dx, so we will differentiate this. Differentiating y with respect to x, we have dy by dx is equal to d by dx of cos inverse x. So this implies dy by dx is equal to, so derivative of cos inverse of x is minus 1 by square root of 1 minus x square. So here we have to find the second order derivative, right? So we have to differentiate this again. So you have two ways of differentiating it. Once you can use u by v rule and you can use chain rule. Okay, so I will solve using chain rule. For that I am going to change this part here. That is, if you have 1 by square root of 1 minus x square, so you can write this as 1 divided by 1 minus x square to the power half, right? Square root can be written as to the power half. So if you take this above, you will get 1 minus x square to the power minus 1 by 2. So by the exponent rule, right? So when you have a to the power m, we will write it as 1 by a to the power minus m. Or when we have 1 by a to the power minus m, we will write it as a power m. So using this, so therefore we will write dy by dx is equal to, minus is there, this we will be writing as 1 minus x square to the power minus 1 by 2. Now we want d square y by dx square, so we will differentiate. Differentiating dy by dx with respect to x, we have d by dx of dy by dx is equal to minus d by dx of 1 minus x square to the power minus 1 by 2. This implies derivative of the first order derivative d square y by dx square is equal to minus of, so derivative of a function raised to a value, so here we will apply x to the power n. So you will get minus 1 by 2 into 1 minus x square to the power of minus 1 by 2 minus 1. So this implies d square y by dx square is equal to, minus times minus is plus, so you will get 1 by 2, 1, and now we will differentiate 1 minus x square. So d by dx of 1 minus x square. So this implies d square y by dx square is equal to minus times minus is plus 1 by 2 into 1 minus x square to the power minus 3 by 2. Now d by dx of 1 minus d by dx of x square. So we have applied u minus v rule. So this implies d square y by dx square is equal to 1 by 2 into 1 minus x square to the power minus 3 by 2. Derivative of 1 is 0. Derivative of x square is 2x. This implies d square y by dx square is equal to 1 by 2 into 1 minus x square to the power minus 3 by 2 into minus 2x. So therefore, d square y by dx square is equal to 2 by 2 is 1. So you will get minus x into 1 minus x square to the power minus 3 by 2. Now this d square y by dx square is in terms of x alone, right? So you have x variable here. But we want in terms of y alone. That means in the place of x we want y. We cannot just directly write minus y and y here because x is not equal to y. X is equal to cos y, right? So you cannot directly put y and complete the sum. No. If you want to substitute y and y here, then x must be equal to y. But here x is not equal to y. Here x is equal to cos y. That means in the place of x you have to substitute cos y. So this implies d square y by dx square is equal to minus cos y to 1 minus cos square y to the power minus 3 by 2. So we'll write one statement here since x is equal to cos y. I have written the previous step here once again. So now d square y by dx square is equal to minus cos y. 1 minus cos square y will be sin square y to the power minus 3 by 2. So now I will simplify this part here. Sin square y to the power minus 3 by 2. So here sin square y is also sin y the whole square, right? Both are same. Both are same. Both are equal. So in the place of sin square y, I will write sin y the whole square. Okay. In this place, I have written sin y the whole square. Now this is raised to minus 3 by 2. Now sin y the whole square. Here we have 3 by 2. So 3 by 2 can be written as 1 by 2 into 3. Right? 3 by 2 can be written as 1 by 2 into 3. If you multiply, you will get back this. We will maintain that minus sign. Now this implies 2 by 2 will get cancelled, or 2 times half. If you take 2 times half, half plus half, you will get 1, right? So you will just remain with sin y to the power 1. But here you have minus 3. Okay, so this we will write here. So d square y by dx square is equal to minus cos y, and in this place we will write sin y to the power minus 3. Now d square y by dx square is equal to minus cos y. So sin y to the power minus 3. So we can write in the bottom sin y to the power 3. Now again d square y by dx square minus cos y. Sin y the whole cube can be written as sin cube y. Both are same. Now d square y by dx square is equal to, see here, when we have sin square y, we can write sin y the whole square. So when we have sin y the whole cube, we will write sin cube y, so that we can simplify. The only thing is we want to simplify here. So minus cos y divided by, so we'll break this into factors. We'll write sin y and the remaining sin square y. If you multiply, you will add the exponent and you will get back 3. So therefore d square y by dx square will be minus by sin y, cos y by sin y is cot y, and 1 by sin square y is cosecant square y. So now d square y by dx square, this is in terms of y alone.